Alright guys, this video is going to be over resistors. Some of y'all had questions over that, and so I thought I'd make a video real quick to kind of go over some vocabulary that you'll need. These words need to go into your personal dictionary that's inside of your binder so that you can reference them whenever you need to. And so just to start off with, we have resistor. It says it resists the flow, sorry about that, resists the flow of electricity, or it slows the flow of electricity. It still allows electricity to flow, but yet it slows it down. And resistors can range from light bulbs to different shapes and sizes, small and large, and they have different measurements of how much resistance that they provide. So they're going to slow down the flow of energy. And what that means is this is a 9-volt battery, as you can see. And we have the negative, and then we have the positive side. And normally if I was to hook up this LED to a 9-volt battery, what would happen is it may spark for just a second or not at all, because it will overload it if it's too much. And here's the definition of overload. You have going over the amount of current something can hold or move. I'll edit my own definition there. So overload is going over the amount of current something can hold or move. And so these are only 3 volts. That's the amount of electricity that can move through this. That is way lower, or 3 times less than the battery is providing. So this usually runs off of 3 volts. This is 9 volts. If I hooked it directly up to it, it would short circuit. And I know that because I did it to about 10 of these, trying to figure out why I couldn't get it to light up, and then come to find out after watching some videos and reading up on it, I was overloading the actual LED. Another thing to note about LEDs that I didn't know about, that I learned, is an LED has 2 legs on it. If you notice, we have I'll try and turn this the same way. It's slippery in my hand. We have a short leg and a long leg. The long leg and the short leg. This is the positive leg. This is the negative leg. So the longer leg is positive, the shorter leg is negative. That does matter. And that matters because if I was to take this flat battery, the top of it is positive, the bottom of it is negative. I know that because there's a symbol showing me that, positive. I'm going to take the long leg and I'm going to put it on top. And the bottom leg, I'm going to put on the bottom. And when I do that, I get electricity flowing. The circuit is complete, it's flowing the right direction, and we have light and a little bit of heat if you hold it long enough. But if I switch it the other way, I get nothing. Let me switch it back. Something. Switch it the other way. Nothing. No flow of electricity. All right. I didn't know that, so I was overloading these and also setting it up the wrong way as well too. So now, like I said, if I normally would hook up this 9-volt battery to the LED, well, the capacity that this can hold, the LED, is not going to hold the charge, and it will overload it and kill it. That means it will short circuit it or overload it. Another word to know is short circuit. It's accidental direction change of current. In this case, whenever I said too much voltage, 9 volts versus 3 volts, that's going to be an overload. But short circuit can also happen if you set up your wiring wrong. And so what I've done is I've actually taken a 9-volt battery. I've connected 2 alligator clips to it. The yellow is positive. And so if you notice, I took the yellow and I made sure the longer leg is hooked up to the positive alligator clip, which is yellow. And then I have the negative that is green. Okay, now, the only reason I can do this, believe it or not, is I can create a resistor out of the graphite that is in these pencils. says graphite on it. You can't really see it because it's shiny. But I've taken these pencils and I've colored 2 squares on it, or rectangles, I guess you could say. More so accurate, a parallelogram, I guess. Anyway, sorry, math in me. So, what I'll do is I'll show you that the graphite in this is a resistor. It's a poor conductor of electricity, but it does still allow some electricity to flow through. Again, I have my yellow connected to the positive terminal of the actual battery, that's 9 volts, and then the green's connected to the negative. So I'm going to touch the negative to the graphite, and I'm going to touch the positive end of the LED to this, and you will see there's some light that's created. And as I move this back and forth, we actually have what's called a variable resistor. That means dependent upon how close I am to the source of electricity, the bigger the light I get, the more light energy I can give off. As I pull it away, it gets smaller. Now you can't see it as much, but there's a lot more graphite here, and if I start at the end, I don't get much of anything. But as I get closer to the source, I start to get a little bitty tiny light. You probably can't even see it on the video. Let's see if I can bring it down here. Okay, you got a little bit there. But it's definitely evident here that I get light. So for me to use this resistor, it allows me to flow electricity through something that normally would not be able to take 9 volts. It's too much power for this LED. It would overload it and break it, and it wouldn't work again. But since I'm using this resistor, it allows me to move the electricity into it without damaging it or overloading it. So this is a resistor. It slows the flow of electricity, allowing me to use a higher voltage on a lower voltage item. And there you go. Pencil lead or graphite is more accurate, and I can create electricity. Pretty cool, right? All right, this was Resistors with Mr. Fudge. Oh, a little side note. Always have positive connected to the positive. Otherwise, you'll either get a short circuit or you'll get an overload when it comes to these LEDs. Thank you.